In this lesson, we're going to look at properties of logs that are going to become very useful when we start solving logarithmic equations. The first two we'll look at, we've actually looked at before, log base b of b. We'll remember in exponential form, that's saying b to some power is equal to b, and hopefully you recognize that that's 1. And in the second one, b to some power has to equal 1, so hopefully you recognize that's 0. So log base 4 of 4, so if the argument and the base and the argument are the same, it's going to be 1. And the second one, the ln of 1, or the natural log of 1, remember this has a base of e to what power is 1? It's 0. The remaining ones are very similar to exponent rules that you already know. Zoom in here, so we're going to look at the product rule. So recall for just a moment when we dealt with exponents. If I had x to the 5th power times x to the 3rd, this would produce, keep your bases and add your exponents. Well, logarithms really are exponents. So when we have log base b of m times n, this is going to have an addition relationship because this is producing really just an exponent. So this is equivalent to log base b of m plus log base b of n. So the product rule has an addition relationship. The quotient rule, log base b of m divided by n, just like exponents, has a subtraction relationship. This is equivalent to log base b of m minus log base b of n. And the power rule, if you think of exponents, has a multiplication relationship. What happens is this exponent comes out front and is multiplied by the log. So it's n times log base b of m. So we'll do a few examples. Let's look at expanding first. So when we expand, we are going to write this with multiple logs all having the same base. Because what's important to recognize is when these expand, notice that the bases are the same. So in this example, log base 4 of 5x, I'm going to look at the argument, and the argument is held by multiplication. So this is going to have an addition relationship. This would be log base 4 of 5 plus log base 4 of x. If I switch directions and I condense it, the second one is split into 2. It has an addition relationship. So if I combine it into just one logarithm, this would be log base 2 of 5 times y. These properties, you might be asking yourself, why am I doing this? But it will become much clearer as you start to solve logarithmic equations. All right, so now we have the natural log of 12/5. So the argument is held by division. So this would be the ln of 12 minus the ln of 5. They have the same base. The base is e. Switching directions, again, I can do it because they both have a log of base 4. So if I combine this, this is log base 4 of 84 over 12. And you could probably reduce that 84 over 12, but just showing you how we expand and condense at this point. The power rule, I'm going to bring this 5 out front, so 5 times log base 6 of y. Going the other direction to condense it into 1, I have 2 times the natural log of 35. I'm going to make this the ln of 35 squared.